Now that we've learned about hyperbolas, it's time for us to get practice sketching graphs of hyperbolas. And there is a 4-step process that we'll use. We'll go through the process first, and then we'll go through an example or two. So first, we need to sketch the central box, which we can do by plotting the vertices, and then also plotting the 2 points on the other axis, given by B. And the vertices are going to be horizontal if we have x squared minus y squared, and they'll be vertical if it's y squared minus x squared. Basically, whichever term is positive tells us the axis on which the vertices lie. And then we plot 2 points on the other axis, and then we can draw a rectangle that goes through those points, and that is our central box. Once we have the central box, we can sketch the asymptotes, which are the lines that are obtained by extending the diagonals of the central box. Next, we'll plot the vertices, the 2 x-intercepts or y-intercepts. Those will be on the edge of the central box. And then lastly, we sketch the hyperbola by starting at each vertex and then drawing the hyperbola outward so that it is asymptotically approaching those asymptotes. We want it to get closer and closer to those asymptotes. We're going to go through an example or two now so that we can get real hands-on practice, and then there will be several other examples in the linked problems below to get more practice with this. So let's start with one together. A hyperbola has equation 9x squared minus 16y squared equals 144. Find the vertices, foci, and asymptotes and sketch its graph. Now we're given 9x squared minus 16y squared equals 144. This isn't quite the equation for a hyperbola because we know that it needs to be equal to 1. So what we're going to do is divide both sides by 144 so that the right-hand side becomes 1, and this is the standard form of a hyperbola. On the right-hand side, we're left with 1, and then on the left-hand side, we can reduce these fractions. 9 and 144 are both divisible by 9. When we reduce by a factor of 9, we're left with just the x squared up top and then 16 on the bottom. Then minus, and when we reduce this fraction, we can reduce by a factor of 16, giving us y squared over 9. So in standard form, we've got x squared over 16 minus y squared over 9 equals 1. Now we know that this will be a hyperbola where the branches are opening horizontally to the left and right because it's the x squared term that's positive. So in this case, a squared is 16, which means that our intercepts are going to be plus or minus 4, square root of 16. And then b squared is 9, so that means b is 3. So these aren't going to be intercepts, but we are going to plot points at plus or minus 3 on the y-axis because those will help us draw our central box. So we need to draw the rectangle that has horizontal and vertical edges that goes through these points. And then once we've done that, we can draw the lines that go through these diagonals, and those are going to be our asymptotes. And those asymptotes, we can see, are given by the equations y equals plus or minus. Now the slope is 3/4. We've got a rise of 3 and a run of 4, so we've got 3/4 x. So those are our asymptotes. Now the vertices, remember we said that this was opening horizontally. The vertices are going to be at plus or minus 4, 0. And we can actually sketch the graph at this point. Once we've plotted the vertices, we can sketch the hyperbola by drawing the branches so that they're getting closer and closer to the asymptotes. And let's see, on the left-hand side, and we want them to also be tangent to the central box, meaning it's a nice smooth curve here that touches the central box just at one point on each side. So there's our graph. We have the asymptotes, we have the vertices. We were also asked for the foci. And the relationship here is that c squared is equal to a squared plus b squared for the foci. In this case, a squared is 16 and b squared is 9. 16 plus 9 is 25. So we've got c squared equals 25, which tells us that c equals 5. And so we can actually plot those. They're going to be at 5, 0, and negative 5, 0. And if we want to write that out, we've got plus or minus 5, 0. And that is our hyperbola. If we had an example where the y squared term was positive and the x squared term was negative, we would still be starting off with the central box, but then our vertices would be at the top and bottom, and we would be drawing the branches so that they open upward and then downward. You'll see some examples of those in the linked problems below, as well as some examples that are set up a little bit differently. So it's really important to go through all of those examples and get practice looking at hyperbolas from different points of view.